I saw this integral on YouTube. Now I have my way of doing it. Two methods. Two methods. The first method, I start with let x be 1 over t. So the integral becomes arctangent t and d 1 over t. The boundary been changed. Now first I switch this, the boundary so become negative from 0 to infinity. Yeah, that looks better. And arctangent square, arctangent t square, sorry, I forget square here, and a d 1 minus t. Now the reason I'm not expand this because it is already ready for by parts, udv, right? So uv, this uv minus become plus in this one, v du. This is a v, right? Du will be 2 arctangent t, then chain rule 1 plus t squared, and dt. Now this one, well, when t is negative, when t is infinity, no problem. This is 0. When t equals 0, this is minus t squared over t, right? It's negative. When t goes to 0, it's a 0 over 0, right? So we can apply L'Hopital's rule. This is 1, this is 2 arctangent, and 1 plus t squared, right? Then t approaches to 0. This is 1, this is 1, this is 0. So everything goes to 0. So this is good. And this will be plus 2 integral arctangent t over t times 1 plus t squared. Good. Now from here, then I'll apply some other methods. Say, how about Feynman's technique? I let f of a is equal to integral t 1 plus t squared and arctangent at dt, right? At. So we have a initial condition f of a 0 is 0, right? When a equals to 0, the whole thing is 0. And my target integral I is 2 times this one when a equal to 0, or when a equal to 1. Right? So my I is equal to 2 f of 1. Okay, that will be useful later. So, okay, then we take a derivative of f with respect to a. So this will be well, this will be, we take a derivative with respect to a, yeah? So this is a t 1 plus t squared and 1 over a 1 plus AT squared. Yeah, for the arctangent. Then the chain rule times the derivative AT with respect to A, so there's a T dt. So this is simplified into canceling T. This will be dt 1 plus T squared times 1 plus AT squared. Okay, good. Then we use the partial fractions, right? So f prime of A is equal to integral. This is A over 1 plus T plus B over 1 plus AT squared T dt. Yeah, I suppose you know how to determine AB by comparing the coefficients, right? So I save time and I skip that. So A is equal to negative 1 over A squared minus 1. B is equal to A squared minus 1. Okay, just to find AB. Therefore, my integral f prime of A, it becomes the common factor, A squared minus 1. And this will be negative. Integral negative dt 1 plus T squared. This will be plus A integral 1 plus AT squared. And I change the dt to dAt and multiply 1 over A. See, that will be dt. This is the same as dt. So both integrals have been done. So this is equal to minus A squared times 1 times arctangent T, right? And this cancel 1A, so it becomes A squared minus 1. This will be arctangent AT from 0 to infinity. Yeah, this one is easy. This is equal to, this one is equal to half pi minus 0. And that one is also half pi minus 0. So we have a common factor, half pi. Then this is also common factor. Then A minus 1. So this goes to this one. I say this is A plus 1, A minus 1. So cancel A minus 1. It becomes pi over 2A plus 1. Yeah, that is f prime of A. So f of A is integral of that, right? Integral to A plus 1 dA. So that one is equal to pi over 2 natural log of A plus 1. Now we use this f of a 0 is 0. So f of s0 is a 0, implies 0 is equal to, this will be 0, right? This is 0 plus c. So c equal to 0. So f of a is equal to half pi natural log a plus 1. Now my target integral is 2 f of 1. So my I is equal to 2 f of 1. So 2 times f of 1 is this, right? Yeah. So finally I get the answer is this. This is my integral by method 1. Very nice method. Now method 2, method 2, arctangent 1 of x squared dx. Now the method 2, I start with this. The arctangent 1 of x, arctangent 1 of x is an angle such that this is a 1, right? This is x. This is called arctangent 1 of x. And that angle will be equal to arctangent x over 1. In other words, this plus this is half pi. Okay? So my integral is equal to this one, half pi minus this, tangent x squared. Yeah. Yes. All right. Okay, good. Then I use substitution. I let theta be arctangent x. So x is equal to tangent theta. So my integral becomes half pi minus theta squared, right? And d tangent x. So when x equal to 0 is 0. When x equal to infinity, that's a half pi. Very good. Now, the reason I'm not expanding it, because it's already for by parts. See? So I'm using by parts, u dv, right? So it's u v, right, 0 to half pi, minus v du, minus v is this, tangent x, tangent theta, u du is equal to 2 times pi over minus half pi minus theta time minus 1, right? The chain rule, d theta. Sorry, see, it is not clear. Half pi minus theta. All right, then this one, well, when theta is 0, no problem, is 0. When theta is equal to half pi, then we are using L'Hopital's rule. Now, okay, how? This one is a tangent theta over 1 minus half pi minus theta squared, right? Yeah. When theta goes to half pi, this goes to infinity. So this one goes to infinity. Yeah. Then we take the derivative, right? Uh, and I'm not using this method. Now, how about this? When theta goes to half pi minus theta square, tangent theta is sine theta over cosine theta. That's better, yeah. Now, when theta goes to half pi, this goes to 1. So no problem. So we are discussed with this cosine theta and half pi minus theta square. We discuss this limit when theta go to half pi. This go to 0, this go to 0. Then we take a derivative, 2 half pi minus theta times negative 1, right? And this one is sine theta, negative. Then we take a limit of half pi. Theta goes to half pi. This goes to 1. This goes to 0. So everything goes to 0. Wow, it's good. Okay. Now this one's, I take a negative out to become plus. I take 2 out, integral, and half pi minus theta and tangent theta. Wow, it's very good. Now and then what? Then this one is equal to 2 integral half pi minus theta. Tangent theta d theta is negative d log cosine, right? Yeah, it's good. That's correct. Now it's by parts. Du dv, right? udv. So this one equal to uv u negative. Forget negative. Negative 2 uv u times v minus become plus v du. V du. V is a log cosine theta. Du is negative d theta. Negative d theta. Very good. Now this one, well, again, we have this. When theta goes to half pi, no problem. This goes to 1, right? 1 times log 1 is 0. So 0 times 0 is no problem. The problem is when theta goes to 0. This would be go to, when theta goes to 0, when theta go to 0, log 1 is 0, no problem. When theta goes to half pi, we have a problem because this one goes to 0. Log 0 is infinity. this go to 0. 0, infinity is a indeterminate form. So, okay, we are solving this one, right? This has no problem. Now, so theta goes to half pi, we have a problem. The problem is this. The problem is this. When theta goes to half pi, this goes to infinity, this goes to 0. So we rearrange this one to log cosine to 1 over half pi minus. Yeah. Okay, this one is equal to this one. When theta goes to half pi, this is infinitive, this is infinitive. So we can use L'Hopital's rule. So L'Hopital rule says this is a negative sine over cosine, right? This one is equal to half pi minus theta square, and the negative become plus. Okay, then this one goes to 1 when theta goes to half pi. So it becomes like half pi minus theta square, right? It's negative cosine. So sine theta goes into 1. Now when theta goes to half pi, this goes to 0, this goes to 0. So we can use L'Hopital rules again. So this one 2 half pi minus theta times negative 1. This one goes to negative sine. Okay, this goes to 1, this goes to 0. So this one goes to 0. Wow. But I hope I explained. So everything goes to 0. So this is 0. This goes to 0. And minus twice 0 half pi natural log cosine theta d theta. Okay. Now log cosine theta d theta. Well, if we use theta is equal to half pi minus theta, say what t, okay? Then this one goes to what? This one goes to log sine t. And this negative dt, yeah. And this would be when theta is 0. This will be half pi. This is 0, right? So use this negative to switch them. So half pi log sine. See, what I want to say is this. This is equal to this. So sine, cosine, there's no difference. Okay. So this one is equal to negative half pi natural log sine theta. Okay. Now, I don't want to repeat here to integrate this one because I have a video showing this integral. The link is below. You can go see it, the detail. So this one is equal to negative pi over 2 log 2. This one is this. See, the link is below. I hope you're welcome to see the details. So the answer is pi log 2. All right. So that is the same result for this integral by method 2. Well, I hope you like it. Thank you.